Welcome. In this video, we are going to look at yet another example on speed, velocity, and acceleration. The question says, just as a car starts to accelerate from rest at a constant acceleration of 2 meters per second squared, a bus moving at 20 meters per second passes in a parallel lane. Question A, how long does it take for the car to overtake the bus? B, how fast is the car moving then? C, how far has the car gone at this point? So this is the question that we're going to consider answering in this video. So without even wasting time, let's come up with the equations since we have two objects. First, let us come up with the data. Let us come up with the data. We have data. A is 2 meters per second squared. Then V is equal to 20 meters per second. Now let us come up with the equations of motion for each object. So for the car, we have motion of the car. Since it is starting from rest and moving at this acceleration, or since it is coming from rest, we have x is equal to ut plus half at squared. This is the common equation for an object that is accelerating. Now, so this one, for the car, initial velocity is 0. Okay, so this is for the car, this is for the bus. So here we have x is equal to 0 plus half at squared. X is equal to half at squared. We can call this as equation 1. For the bus, motion of the bus, it is moving at a constant velocity, and we know that velocity is equal to displacement over time. Making this the subject, we are going to have x is equal to bt. So let us call this as equation 2. And this is the equation for an object that is moving at a constant speed. From this point, we know that this is displacement and this is displacement. And in order for the car to overtake the bus, then both the car and the bus must cover the same displacement. And this is displacement of the car, this is displacement of the bus. So we can say this displacement is equal to this displacement. So equation 1 is equal to equation 2. So equation 1 is equal to equation 2. So equation 1, we have half h squared is equal to this one, x is equal to vt. So equation 2 is vt. So now we want to find how long it takes for the car to overtake the bus. So it is time that we are looking for here. So we can multiply by 2 here and also here by 2 so that we get rid of this half. And we're going to have h squared is equal to 2bt. We can divide through by t and also here by t so that this and this will go, this and this will go, and we're going to have h is equal to 2b. From this point, we can divide by a and also here by a so that this and this will go, and what we're going to have is t is equal to 2v over a. So this is the expression that we're going to use, and this is the one that we use if we want to find the time something is going to take to overtake another thing, an object to overtake another object. So this is the one that we use because they cover the same displacement. So from this point, we are going to proceed as follows. Let us plug in now the values so that we find how long it takes. So let me just erase this. So for A, we have T is equal to 2V over A. We put in the values now. 2 times, this is 20, which is this one, meters per second over, we have 2 meters per second squared. 2 meters per second squared. And what we're going to have, this one and this one will cancel, and what we're going to have is plus this. From this point, we can go to part B. How fast is the car moving there? So how fast is the car moving? We are here, we are looking at the speed, or want to figure out the speed at which the vehicle or the car was moving as it was going to overtake a bus. So we have the equations, we have this one, A is equal to V minus U over T. If we transform this, we're going to have V is equal to U plus AT. So this one and this one yield the same answers because this one is the transformation of this one. Then we have V squared is equal to U squared plus 2AX. But depending on the information that we have, we do not have X yet, so we cannot use this equation. Then we have X is equal to 50 plus half AT squared. Here we want how fast, so we do not have velocity, so we cannot use this one. So we can just use this or this. So let us plug in let us use this one and okay, V is equal to U plus AT. U is 0 plus A, 2 meters per second squared times 20 seconds. From this, what we're going to have is a second here will cancel and we're going to remain with the units 40 meters per second, 10 meters per second, the units for velocity. Now the final answer or the final part, it must find how far the car has gone at this point. So it is simply about the distance the car has moved in order to overtake that. So we have C, we can use either this equation or this equation since we have X and here we have X. So let's try the first one, which is V squared is equal to U squared plus 2AX. Let us put in the value. We have 40 here. So 40 squared is equal to 0 squared plus 2 times 2x. So here we are going to have 16, 0, 0, which is equal to 4x. We divide by 4, also here by 4. So that this and this will go, and what we're going to have is x is equal to 4 into 16. It is 4, then these zeros. So we have 400 meters. Let us try also this one so that we see if it is going to work, of which it should work. So we have x is equal to ut plus half at squared. So here we have 0 plus half times 2 times 20 squared. This and this will go, and what we're going to have is 20 times 20 is 400 units meters. So this is displacement. This is how far the car will